All right, so once again, I am at NYU Future Labs with the AI Nexus companies, and this time I'm with Mutisia Ndunda, the co-founder and CEO of AlphaVertex. Say hi.
Hi, thanks for having me.
So why don't we get started by having you tell us a little about Vertex and what you guys are up to.
Sure. So AlphaVertex is an innovative financial technology company that is using the next generation of AI tools to help support investing around the world. Practically, what that means is that we develop predictive models that try to forecast the returns of stocks over multiple time horizons. Okay. And at present, we cover all major markets around the world. So we cover 30,000 stocks globally, which represent about 95% of the investable universe.
Okay. And so presumably you came out of financial services prior to this?
Yeah. So my background is in finance. I've spent over 17 years. I started out in investment banking, did private equity, and ended up as the chief of staff of one of the largest proprietary market-making businesses in the world at a company called Susquehanna International Group. And then after leaving that, I spent 5 years at Bloomberg as the head of strategy and business development for Bloomberg Enterprise Solutions. Okay. So I've kind of done my tour of duty around Wall Street and around Wall Street service.
You've got quite a few punches on your ticket. It strikes me that of all the companies that I've talked to here at AI Nexus today, the trying to help people make better trades with financial data is there's nothing new about it, right? That is a classical idea, and lots of people have tried to apply. We've been trying to apply analytics to this for many years. What is new and different about your approach to it?
So I'll first just start by sort of saying you're absolutely right that it is not a new idea because it's not a new problem. But the present moment, there's about 98% of all funds underperform their benchmark over 10 years. Mm-hmm. And the simple reason is that they rely on kind of traditional portfolio managers to act as stock pickers. Mm-hmm. And what happens there is that you have maybe 1% of all fund managers are kind of really good at making money, but then the 99% of the population ends up underperforming. And so you're subject to kind of the talent that you bring in. As financial markets get more and more complicated, there's about 2.5 billion bytes of data nowadays that people kind of have to keep track of. It's increasingly difficult for a human being to sort of incorporate all of this information in a useful way into the investment strategy. So with the onset of innovations in machine learning and AI in general, we're able to build models that can capture all of these pieces of information, much similar to the butterfly effect. So if you think about, we have AI models that sort of will see things that are happening in Asia and then model how they ripple through global markets to affect a stock like Apple or Google in the US. It's really, really challenging to be able to do that as a human being or to build a model that can capture that complexity. So that's sort of what we're doing that's completely different is we have these very sophisticated models that can kind of look out to 10 or 20 degrees of separation away and analyze how things that are going on in very distant places can kind of ultimately come back to impact stocks that people. Mm-hmm.
So certainly the hedge funds have been trying to apply this type of stuff for a very long time. Is part of what you're doing, bringing the quant type of technology the hedge funds have been doing to the traditional investors, the institutional side?
Yeah. So we, interestingly enough, the earliest adopters of our technology are obviously the quantitative or systematic hedge funds. They kind of understand how powerful this technology is, and they employ data-driven, technology-based investment strategies. And so this, to them, is a high-value signal that is additive to maybe other things that they do on a proprietary basis. Ultimately, over the long run, what we want to do is make these tools kind of more broadly accessible to the 99% of the investment managers out there that don't have, this technology-driven investment platforms. So we're working on things like having, kind of machine learning-driven institutional class research and analytics facilities that, can be accessed via natural language. So you don't have to have the technical capability of a data scientist or a statistician or a PhD person to be able to do the types of analysis that we're going to be developing. So I think, in the near term, the early adopters are the more quant-driven hedge funds, but over the long run, we want to go after everybody in this space.
Okay. So you guys are, it's not so much arming the folks that can't keep up with the quants. It's you guys have developed some really cool stuff that the quants need too.
Absolutely.
Okay. And so, thinking about how one might try to build machine learning AI fly effect, that sounds super complex. Like, what's the approach there?
So it is actually a pretty huge problem. The first thing is you have to try to represent all the world's financial information in a way that makes sense.
Oh, well, that's easy.
So that's... So the approach that we've taken is we've modeled everything as a computational graph. And for people who aren't familiar with that, it's literally this multidimensional relationship map of how everything is interconnected to everything else. So you can describe things like Apple competes with Samsung, Apple is a customer of Samsung's, and Apple is suing Samsung. And all of these are relationships between these two nodes or these two entities. In a traditional model, you can't represent these multidimensional relationships across companies. And in our case, like in the case of where Apple is suing Samsung, the relationship has a direction. So Apple is instigating the legal lawsuit on Samsung, and we can encode the value of the lawsuit, how long it's been going on, and then you can actually do computations off of all of these connections between companies. But to do this, you have to monitor all the world's information, not just financial information. So to be able to just do that, we monitor over 1 million pieces of information in a given day. And these are across all types of sources. So we look at structured data sets like financial market data. We look at unstructured data sets such as regulatory filings with, say, the SEC, the FDA, whatever. What companies are saying in press releases, news articles. We read about 300,000 sources of news in a given day. And one of the things we had to build early on was this ability for the machine to understand the news on its own, extract relationships that it thought were meaningful, and then also weigh the quality of that source of information. So not all things are created equal. If I read something on a blog in Asia, it might be actually a really high quality source, or it may not be. And so, you have to make these autonomous machines have the capability to sort of weigh the quality of the source of that information. And once it's extracted, and you're putting it into this computational graph, it has to say, I think this is actually a really good fact. Or if it's not, then it says, it's not a high quality fact, and I need to wait on confirming or additional sources of, to confirm this relationship that I just found. And that's just the starting point, right? So we cover, 80,000 publicly traded companies around the world. We monitor 15 million private companies, and we track about 200 million people that work at these companies as a starting point. And then from there, we try to figure out all their products, who they do business with, whether they're contracting with other companies or with the government, any kind of litigation that may be going on, who their investors are and what their investors are doing. So, it's this spider web of knowledge that we have to build before we can actually do a computation.
Right. So there's so much in there. Like even just the issue of trying to identify the newsworthiness, the trust level associated with a given site. I mean, that's Google, right? It's PageRank, right? Are you using something similar to PageRank in?
Yes, but no. So, Google's an amazing piece of technology, but again, with machine learning and a lot of things that we do, the domain knowledge is extremely important. So Google doesn't have PageRank for finance, right? So we kind of have to build that ourselves. The good thing is, I guess Google tries to index the world. We just need to index the financial world. So it's a subset of what Google does. But we can take a lot of the same concepts from what Google does and incorporate that into our own algorithms. One of the things that we've done is we apply like this machine learning approach to teaching things whether or not this is a high quality source. So we can give the AI good examples of what high quality, like this is the Wall Street Journal, this is a high quality source. These are the types of relationships or pieces of information that come from this source versus here's a, like a no-name blog, and then the machine can kind of extrapolate from there.
So it's a supervised learning problem as opposed to go out and index all of these financial sites and figure out which ones are high quality the way Google.
Yeah, because Google basically has boiled the ocean ahead of time, and we kind of, when we come across new stuff, we make a determination at that point in time.
Right. That's super interesting. Tell us about some of the other interesting kind of machine learning problems that you...
Yeah. So the other thing that is actually really, really hard to do is kind of twofold. The first one is entity resolution. So you're reading all of this information about people, places, companies, whatever. The way things are written is not necessarily always clear. And so you might be reading something about Apple, but it's the fruit and not the company, and you have to be able to disambiguate that. So we do a lot of really cool stuff in the entity resolution space. And then we've started to do some really exciting things that were in the domain of intelligence services, but I think kind of the technology is leaking out now in the sense of something called record linkage. So if you have these giant data sets that you can onboard or acquire or create yourself, what typically happens is that something may call Apple in one data set. It may call it Apple Inc. in a different one, or it might just be a reference to the CEO of Apple. So you need to be able to link all of these data sets together, and basically you don't have a clear key on which to join everything. So you have to make these calculated sort of, similar. You have to basically say this thing is likely this other thing.
Disambiguating.
Correct. And connecting things based off of, you say, is this in the same location? Or, is it referencing a product of this company? So, and then basically be able to say, well, actually it is talking about Apple, but it was actually talking about the iPhone. So basically merging, like, say, the iPhone to the Apple the company without ever having a necessary mention of Apple in both data sets. Right? So the record linkage is actually really, really, really hard. We've started to do a lot of that, and it's a really fascinating kind of area in the big data world.
How do you attack that? What technology approaches are you applying to?
So obviously the first one is we have to be able to, within the data, extract kind of attributes or features that we think are important for the links that we're trying to establish. So we might
what
say...
are we trying to link in the first place?
So company data. So if we go and grab every patent in the US for companies, and that's just one giant data dump. Linking that back to, well, all these patents are actually owned by these companies. The US government and patent office might not have the same names as, the publicly traded companies themselves. So you have to look at things like, is the address the same? Are the people mentioned as the patent holders employees of these companies? So you're looking for bodies of evidence that suggest that these two things are kind of mapped together. And you have different algorithms that can kind of give you a score and a confidence measure as to how closely two records are to each other. So that's one. And then another one is a thing called relationship extraction. So if you read a piece of news as a human being, it's very easy for you to sort of boil it down to what it means, right? So, this company is buying another company.
Right.
But in the real world, that might be written out over 3 paragraphs. And so for a computer to sort of establish that entity A is acquiring entity B after reading a paragraph or 2 is actually a pretty challenging problem.
Right.
And so, there's a lot of really interesting stuff that we use there, but most of it is in the deep learning, kind of space. So we're using a lot of TensorFlow models that, to try to understand the representation of language. extract kind of entities and then the relationships that we're looking for.
So do these end up looking like, single or individual, like super, very deep neural networks, or are they many neural networks that are each serving their own purposes?
That's a great question. Yeah, so what we've realized is that we've had better results with building specialized machine learning models and neural networks, as opposed to one kind of generalized AI or generalized network. And so even with our relationship extraction, what we do is we have thousands of models that kind of work in unison, and each one is highly specialized in one thing. And so if you think about having a very wide funnel at the beginning where you say, this is a raw document, the first sort of set of models will basically say, this document is actually talking about this concept. And then that gets filtered into, okay, so within this concept, these are the types of relationships I should be looking for. And then have more sophisticated models kind of take that information and then say, okay, fine, so this is about a corporation, and corporations can have M&A as a relationship. And so I'm seeing a very strong signal that this document in general is talking about M&A. Let me give it to the more sophisticated guy to go and extract that very specific relationship.
And by sophisticated guy, are we talking about a person or another model?
Another model, sorry, yeah. And so we have this kind of pipeline of AI models that kind of work together, that start really broad and then end up kind of very hyper-specialized at the end.
And are you doing any human in the loop anywhere, or is it all?
We do, but it's there's a bit of reinforcement learning that goes on, especially with the record linkage stuff. And then we obviously retrain our models fairly frequently, and so we'll have the human in the loop on the retraining of the models. But on a given day, everything's kind of running in an autonomous fashion.
That's super interesting. So, when you talked about the identifying the relationships and how you have you can have the 3 paragraphs to get to, that there was an acquisition. That makes me think of CFO speak, right? Do you have a model that can train, that is trained to decipher when a CFO is saying that they're going to miss?
Actually, it's an area of interest to us. We haven't yet done any kind of real hardcore development there, but there is actually a huge community of users in the kind of, hedge fund space that want to understand tone, not even just the text, but the tone. Yeah. If there was video of the guy making the statement or his eyes darting around. There is a lot of kind of interest in that. We just haven't yet had a chance to spend the time in that space. But it's clearly something,
Okay. And so where are you guys in the process?
So we've launched a product about, I guess, less than 2 months now called Precog, which is it's a predictive service that basically tries to measure the butterfly effect and then produce short-term forecasts for the returns of these 30,000 stocks around the world. That is currently in production, and we have a number of clients that we service.
So meaning you give it, a company, and you probably have some unique company thing. Will just go into its database and tell you, and you give it maybe say 30 days, and it'll tell you a projected stock price in 30 days. Is it?
Yes, it's along those lines. So what we do today is we only produce predictions on specific time horizons. So it would be like a 1-week forecast, 2-week forecast, or 1-month forecast.
Okay.
But it would be kind of a rolling day forecast for those horizons. So today being Monday, we'll give you a forecast for the return of the stock, not the price, but the return of the stock by next Monday. 7/14
in 30 days. Yeah. Okay.
And that, again, if you do this systematically over a broad universe of stocks, and you sort of, you're never going to get 100% accuracy, which is impossible. But you have this winning prediction. Right now, we think we get anywhere from 60 to almost 70% accurate, depending on the horizon and the stocks themselves. But 60 to 70 is kind of the average. But across 30,000 names, that is like Vegas odds, right? So if you're the casino, you may lose a hand to one player one table, but across all players, you're systematically making money. And so the customers that are using our predictions want them on a very large universe of stocks. And then they are obviously not betting the farm on one prediction on one day. They're making.
This is one signal that they're using out of a portfolio of signals. Yeah. So you're obviously gaining. You're able to make a prediction at day 0, and then at days 17, 14, and 30, you're getting additional signals as to how accurately your model is performing. How do you then use that signal to retrain, and then how do you deal with like attribution issues? You were off by 50% or even plus minus. Like where in your model did you go wrong? Have you started to look at that?
Yeah, we do. One of the things that we've tried to shy away from just kind of with our models is that we've tried to avoid using deep neural nets and all of these types of things when we're doing our forecasting. And the reason being with these deep neural networks, you actually don't know kind of what is driving the model's decision to produce the outcome that it produces. So the models that we generally rely on tend to have a way to sort of reverse engineer why it made the decision it made.
So more like decision trees or something else?
It's never one thing. So we use kind of a hybrid approach where we will use an ensemble of methods to come up with a single prediction.
Okay.
But most of them have an ability where we can actually query the model and ask it what was the most important thing in the decision that you made.
Okay.
And then those weights or those factors are things that we can kind of just sanity check in the markets to see if it is what it was. So we make, say, for financial stocks, we think yield spreads and things of that nature should be important to financials, but there may be a group of financials that aren't moving with respect to interest rates. So the model might rely on that, but then in a month's time we could go back and say, well, why were you way off? And they'll say, well, I overweighted this move in interest rates.
Okay.
And we will try to retrain the model to make sure it doesn't do that. Okay. The thing we try to do is we don't want to superfluously or just over engineer the models, because you can end up with overfitting.
Right.
So we're really careful about when we train the models and then what we give them to retrain. And there's a lot of art and science that goes into kind of being like 60% is good enough or not, given everything that we know.
So it sounds like, going back to your funnel analogy, at the top of the funnel, you're using a lot of deep learning to extract signal from various sources, and then closer to the end of the funnel, you're using more using models that have greater explainability.
Absolutely, that's correct.
Okay, interesting. Anything else that you'd like to share about what you guys are up to?
Just kind of long term. One of the things, obviously, we're trying to build, like I said in the beginning, was the capability for then non-technical users to be able to sort of surface some of these insights, or even discover new facts that are kind of not obvious, right, within this knowledge base that we've built, and then also be able to take advantage of some of these predictive models that we're building. So what we're really trying to do here is develop an ability for the machine to understand human intent. Mm-hmm. And then also the context in which the intent is being asked. So, for example, you sound fairly kind of familiar with the financial domain, but like my grandmother may have a similar question to you, but the response that the machine should give her versus you needs to be kind of adjusted for that. So we're really looking to build an intelligent agent that would be able to work under different contexts, right? So if you're dealing with another professional investor, you're kind of having a conversation at that level. If you're dealing with somebody looking for financial advice who's not that sophisticated, then you kind of want to boil down some of these things and just have them explained back to the user in a format that they can understand.
Right.
So that ultimately is sort of where we're driving towards.
Okay. Where can folks learn more about what you guys are doing?
So on our website is a great place to start. They can also check out, at least for individual investors or people interested in sort of these signals that we're producing, they're available on Quantopian. And they're free to use until you want to put them into a production strategy.
Okay.
And they are available for 500 of the most liquid names in the United States.
Okay. And so the company website is
AlphaVertex.ai.
AlphaVertex.ai, and Quantopian is the site that's
It's a platform where some of this information is available.
Okay. And if folks want to get in touch with you, can they do it through one of those sites?
Yeah, they can email me at info@alphavertex.ai. And,
okay.
We will be glad to reach out to them and just understand what their needs are.
Awesome. Well, thanks so much for being on the show. I really learned a lot from what you guys are doing, and it sounds really exciting.
Yeah, it was a pleasure. Thank you so much.
Great. Thank you.